It's a towering achievement. Kenya's standard gauge railway, built and 90% financed by the Chinese, it will run almost 300 miles from the port city of Mombasa.
A railway now soars above Kenya's savannahs, where elephants pass beneath towering concrete spans, cutting travel from coast to capital to under 5 hours. A trip that once took more than a day. Built in under 3 years, this record-setting elevated line transformed East African transport. Its rapid rise wasn't accidental. It emerged from urgent local needs and a powerful global push to reshape infrastructure. Blending bold engineering with geopolitics, the project signals a new era, and a model others may soon follow. A high-stakes infrastructure crisis. Kenya's transportation system was crumbling under the weight of outdated technology and increasing demand. For decades, the only railway linking the port city of Mombasa to the inland capital, Nairobi, was a relic from colonial times, built over a century ago by the British and barely maintained since. Trains crawled along rusted tracks at speeds closer to a slow bicycle than a modern freight service, turning what should have been a few-hour journey into a day-long ordeal, sometimes stretching to 2 days. Road transport offered only a marginal improvement. Trucks clogged a single main highway, frequently broke down under the relentless heat, and added massive costs to moving goods inland. The result was an expensive bottleneck that crippled businesses and inflated prices across East Africa. Moving a container from Mombasa to Nairobi costs more than shipping goods across many entire European countries, a statistic that speaks volumes about the urgent problem Kenya faces. This failure to modernize transport infrastructure wasn't just inconvenient, it was a severe constraint on growth. Local farmers couldn't get their produce to market in time. Factories struggled to receive raw materials promptly. Clinics in rural areas faced long waits for essential medical supplies. Every day, businesses lose money, and the entire national economy is dragged behind more efficient global competitors. The aging railway itself was deteriorating faster by the year. Heat-warped tracks, crumbling bridges, and unsafe stretches forced sections to be abandoned. Entire shards of the line became unusable, further isolating regions and reinforcing the need for something far more ambitious than patchwork repairs. Kenya's economic future demanded a vision that could leapfrog decades of neglect. The challenge was clear: rebuild or replace a critical artery with modern infrastructure capable of coping with 21st century logistics demands. Yet, the scale of what was needed, coupled with Kenya's limited financial and technical resources, made such a project seem nearly impossible. No local or regional actor had the capability or capital to tackle this infrastructure crisis comprehensively. Businesses and government alike faced a stark reality. Without revolutionary change, a whole generation would remain shackled to the past. The question was not whether, but how and with whom Kenya's transportation nightmare would be solved. And then came a surprise that no one saw coming: a partnership that would rewrite the rules of African infrastructure development forever. China's game-changing offer. China made an extremely appealing offer to other nations in 2014. The Export-Import Bank of China, which operates as a state-owned financial institution, provided Kenya with a loan that totaled about $3.8 billion. The situation extended beyond financial matters. China presented complete project management to the China Road and Bridge Corporation, which would manage all project phases from initial design work to final system operation. The partnership involved more than just financial arrangements because it served as a strategic asset for China to expand its Belt and Road Initiative throughout the world. The initiative functioned as a geopolitical strategy that enabled China to expand its power through building infrastructure in Asia, Africa, and other regions, while providing export markets for its steel and machinery and technical knowledge. The construction of Kenya's railway system enabled China to expand its industrial base while establishing permanent commercial ties with the country. China provided more than financial resources and equipment because the country delivered exceptional engineering expertise along with dedicated personnel who possessed experience in managing extensive infrastructure development projects. Chinese engineers arrived early, deploying satellite data and aerial surveys to meticulously map the entire 500-kilometer route. Their method used advanced technological solutions together with practical field knowledge, which had not been seen before in African building projects. The strategy allowed Kenya to acquire both a railway system and the ability to transfer skills and advanced technologies to its workforce. Local workers received training in Chinese construction techniques, while Kenyan engineers of the new generation understood how to handle advanced modern machinery and systems. The extended advantages reached beyond the railway system because they improved the country's workforce capabilities. The agreement created a situation in which both parties achieved beneficial results, according to China. The loan repayments, which extended over multiple decades, would create ongoing capital outflows together with equipment and diplomatic control. Beijing established itself as the essential ally for Africa, as all economic activities shifted from one area to another. While some people refer to it as smart diplomacy, and others view it as an economic strategy, the resulting project received high visibility because most people believed it would remain dormant until China became involved. The plan demonstrated extraordinary daring because it sought to construct a contemporary standard-gauge railway system that would mostly run on elevated tracks across 500 kilometers of extremely difficult African terrain within a 3-year period. The goal appeared unachievable until China made its offer, which provided actual details to support the achievement of the target. From a high-stakes opportunity, the plan quickly became a race against time and nature itself. Engineering against nature. Kenya's natural landscape posed one of the greatest engineering challenges imaginable. A vast expanse of flat savanna dotted with loose, shifting sandy soils. Building a railway that weighs hundreds of tons over a surface that moves and crumbles underfoot required ingenuity and perseverance beyond standard construction protocols. Engineers couldn't simply pour concrete on unstable ground and hope for lasting stability. They had to transform the very earth itself. The first step was leveling and stabilizing the terrain. Hundreds of bulldozers rumbled across the project site, flattening hills and filling dips to create an even base. Yet flattening the ground was only half the battle. Loose sand simply cannot bear the weight and stresses of a modern elevated railway without shifting and sinking. A delicate balance of moisture and compaction was needed. To achieve this, teams sprayed water onto the sandy soil through specially designed spraying arms. Adding moisture caused sand particles to stick together more firmly, much like when a pinch of water turns dry flour into dough. With the soil densified, the process moved to the next phase, applying raw force. Massive cranes, each lifting steel weights equivalent to the mass of a medium-sized car, repeatedly dropped these loads onto the ground. These impacts sent shock waves deep into the earth, compressing the layers and expelling air that created weaknesses. Over time, the soil beneath became almost as firm and solid as bedrock. Following this, giant rollers passed repeatedly over the surface, pressing down the earth like enormous irons flattening fabric. Each pass further tightened the soil, turning once soft savanna sand into a dense, stable foundation. Workers capped the process by spreading thick layers of Kenya's distinctive red soil, which was itself compacted to add extra strength and durability. This intricate process was repeated kilometer after kilometer along the entire route, with teams working in rotating shifts to maintain non-stop progress, despite daytime temperatures soaring above 30 degrees Celsius. Every segment was rigorously measured and tested to ensure the ground had met strict engineering standards before construction above could begin. The transformation was breathtaking. What had once been shifting, unreliable sand was now a firm platform capable of supporting cranes, concrete mixers, and the massive steel pillars to come. This groundwork set the stage for one of Africa's most astounding engineering marvels. With the earth hardened and ready, the real spectacle, the forest of towering concrete columns, was poised to rise. From the resilient earth beneath to the towering structures above, the story of Kenya's elevated railway showcases a blend of raw engineering power and meticulous planning. But the project's physical might was just the beginning. Rising concrete giants. The process of building the elevated steel and concrete highway system across Kenyan territory began after workers completed the foundation work. This modern railway system operates mainly above the ground through its network of concrete pillars, which support its tracks. The pillars reach a height of approximately 15 meters, which equals the height of a 5-story building, and they weigh approximately 90 tons. The pillars create an effect that makes them appear as a gigantic concrete centipede that moves across the savanna until it reaches the horizon. The presence of one of these pillars gives people the experience of standing between tall buildings, because each pillar supports the weight of the trains and bridge decks that exist above it. Workers constructed each pillar through an on-site process that utilized steel molds to create high-strength concrete, which contained steel reinforcement bars. Workers needed to maintain accurate measurements because the combination of extreme heat from the sun and temperatures beyond 30 degrees Celsius presented a challenging task. The process of constructing thousands of these gigantic pillars required workers to execute their tasks with extreme accuracy while performing repetitive activities. The bridge deck experienced disruptions because even minor misalignments created problems that demanded expensive repairs and required time to be fixed. Workers continued their task by establishing an unbroken work pattern, which permitted concrete columns to complete their curing process before workers progressed to the subsequent column, which extended throughout the entire project, covering 200 kilometers. The project required a massive quantity of work, and it demanded an extraordinary amount of time to complete. The railway's elevated structure had its 3 supporting pillars, which functioned as its main support mechanism. The bridge deck required its flat surface to be constructed through the direct connection of its supporting pillars, which needed to be done through precise measurements that guarantee strength between both points. The project used precast girders, which consisted of massive concrete beams that measured 30 meters in length and had a weight capacity of 100 tons. The local manufacturing facility produced these girders through a process that involved creating precise molds, which included high-tension steel cable reinforcement inside the concrete beams. The construction site received the completed girders, which construction workers used a launching gantry system to move into their designated positions. The gantry system moved along pillars, which it used to extend forward and pick up each girder, which it positioned between 2 supporting columns. The construction site operated with an extremely small margin for mistakes, which permitted only minimal measurement deviations because any measurement beyond 3 millimeters would create a hazardous situation for the bridge deck. The industrial operation functioned as a precision dance that depended on basic physical force to achieve its objectives. The hydraulic machines activated their steel cable tensioning process, which created an additional force to establish permanent beam security through the process of locking girders into their designated positions. The construction team used protective materials to shield the building components from rust damage, which would occur in the high humidity and temperature-changing environment of the site. The deck construction progressed with the installation of beams, which advanced at a rate of 30 meters per segment through multiple environments that included valleys, rivers, and wildlife corridors. The railway system built its elevated tracks, which enabled train operations to continue through the Nairobi National Park without harming any animal habitats in the area. The elephants move through the space while the trains travel above them without making any noise. The design enables construction above protected land because it utilizes engineering methods that do not require building fences or creating crossing points to enter the area. This forest of concrete giants transformed Kenya's transportation landscape well before the rails and the trains ever touched the ground. Industrial might and precision. Once the lofty concrete bridge deck was complete, the next phase was laying down the rail infrastructure itself, an enormous industrial challenge often overlooked when marveling at the visible pillars. Steel rails don't simply appear ready-made. They begin as hefty steel blocks called billets, each weighing several tons, heated in giant furnaces to temperatures around 1200 degrees Celsius. At this heat, the steel becomes soft enough to flow and bend without shattering, allowing it to be shaped precisely. The glowing billets pass through a series of rolling mills, machines that act like a pasta press for metal. Each pass squashes and stretches the steel, gradually forming the exact profile needed for railway rails. A wide flat base, a narrow vertical web, and a rounded top where train wheels will roll smoothly. By the end of this process, a single piece of rail can stretch up to 100 meters, roughly the length of a football field, shaped from what began as a small steel block. Once shaped, the rails cool slowly and carefully to avoid warping or cracking, then pass through straightening rollers and are cut to standard lengths for installation. But steel rails alone don't make a track. Beneath them lie concrete sleepers, rectangular blocks that firmly hold the rails in place and transmit the enormous pounding of heavy trains into the ground. Each sleeper measures about 2.5 meters long and weighs between 250 to 300 kilograms. They are made from pre-stressed concrete, meaning steel cables inside the blocks are tensioned before the concrete sets, giving them immense strength and resilience against cracking and wear. Attached to each sleeper are metal clips, plates, and bolts designed to hold the rail tightly, preventing sideways shifts during high-speed travel or sudden braking. To grasp the scale, consider that every kilometer of railway requires between 1,600 and 1,700 sleepers. With the line stretching nearly 472 kilometers, this means hundreds of thousands of precisely manufactured blocks had to be produced, transported, and installed, each one a crucial piece of the puzzle. Rails and sleepers were pre-assembled into modules roughly 12 to 15 meters long, each containing 20 to 25 sleepers, allowing crews to place large track sections onto the bridge deck quickly and efficiently. This modular approach minimized manual labor and sped up construction, vital for meeting the tight timelines of the project. After placement, these sections were meticulously aligned to maintain the standard gauge of 1.435 meters, the critical width separating the rails that ensures safe and stable travel. Finally, using a method called thermite welding, the ends of the rails were fused together into one continuous ribbon of steel. This process melts the metal at the joint with intense heat from a chemical reaction, creating seamless connections that eliminate bumps and weak spots. This continuous rail allows trains to glide silently and swiftly across hundreds of kilometers, transforming a historic colonial-era nightmare into a rapid, reliable artery for East Africa's growth. From giant concrete pillars to seamless steel rails, the engineering feat is astonishing. But the real story lies in how this transformation reshaped Kenya and a continent's economy and connectivity in just a few short years. Impact and controversy. The train service between Mombasa and Nairobi started in 2017 when the first train made its journey through the route, which took about 4.5 hours to complete. The project transformed all aspects of Kenya's transport because it required more than a simple improvement. The new system enabled trucks and trains to transfer freight between locations at a speed that worked better than previous methods. The new system enabled farmers to reach markets sooner, while businesses established dependable supply chains and passengers enjoyed air-conditioned travel, which took only a small part of their time. The elevated railway sections throughout wildlife areas permitted elephants to move through their traditional migration pathways. The structure demonstrated that large-scale projects can achieve their objectives while safeguarding natural environments. The route improvements resulted in better travel conditions, which subsequently increased business operations throughout the towns that lined the route. The construction sector created substantial job opportunities, which enabled thousands of Kenyan workers to develop their engineering, machinery, and technical system skills. The training program developed local professionals who could operate advanced locomotives and signaling systems, which increased the workforce's operational capabilities. The establishment of new stations created economic centers in areas that had not previously experienced modern railroad systems. The ordinary citizens experienced direct effects from the situation. Traders in Nairobi could receive goods from Mombasa the same day instead of waiting days. Families no longer needed overnight travel, opening more opportunities for work, education, and tourism. The railway provided transportation services that operated at higher speeds, greater dependability, and better access than those available previously. The project has become a topic of public debate because the construction project required Kenya to incur extensive debt, which raised questions about its repayment capacity and about its long-term financial effects. Critics doubt whether the economic benefits will equal the expenses, while others express concerns about relying on international resources and knowledge and skills. While the railway has improved movement, questions remain about maintenance costs, ticket affordability, and whether freight volumes will consistently meet projections needed to keep the system profitable. Some analysts point out that shifting cargo from road to rail requires strong policy enforcement and cooperation from private logistics companies, which does not happen overnight. The project maintains its distinctiveness because of its enormous size and rapid execution. The country received its complete rail network replacement within 3 years after the implementation of the project. The standard gauge railway enables millions of people to travel and conduct business, while it serves as a demonstration of development and an active discussion point about environmental issues and national interests. From collapsing colonial tracks to sleek trains crossing the savannah in hours, Kenya's elevated railway transformed a transportation nightmare into a modern marvel. It's a story of vision, innovation, and rapid progress, shaped by international partnership and local determination. If you found this journey as fascinating as I did, please like this video, subscribe for more incredible stories of global engineering feats, and hit the notification bell so you don't miss what's coming next.